Hi, my name is Christina Chan, and I'm going to teach you about partial fractions a little bit. So, of course, obviously, you're here because you're wondering what are partial fractions? And partial fractions is the opposite of something maybe you've learned before. So, it's the reverse of adding and subtracting rational functions and expressions. So, I'll give you an example. Hey, look. So maybe you've seen this before, but say you have two rational functions or expressions and you want to add them together. So hopefully you've learned before that in order to add fractions, you need to make sure they have the same denominator, right? So you would do this where you make sure the denominators are the same. Then you would have these two fractions that you would combine together to get 30 plus 10x over 6x squared. So maybe you've just seen this before in some sort of way, maybe with or without letters. But today, with partial fractions, it's actually the opposite direction. So notice you're going to be given this, the end product, and what we're wondering is, what can we do to separate these two fractions apart so that they are two separate pieces, two separate fractions? So this is called partial fraction decomposition. Okay, so before we do partial fraction decomposition, I'd like to show you this kind of problem because this is related. So notice in this problem, you have x minus 4 times x plus 1 equals 0. And this is called zero product property. Basically, you pretend that each of these factors are equal to 0. So you set x minus 4 equal to 0 and x plus 1 equal to 0. When you add 4 on both sides, you'll get 4 as x, and when you subtract 1 on both sides, you'll get x equals negative 1. But I want you guys to see the key thing in this here. So these answers, they make this product 0. So say you place in 4 for x, that'll be 4 minus 4, and that's 0, and that ultimately makes the whole thing 0. And the same thing will happen with negative 1. Okay, now you're ready for your first example of partial fraction decomposition. Here in our example is 5x minus 4 over x squared minus x minus 2. And keep in mind, when you do partial fraction decomposition, you're trying to break this apart, So your final piece, you basically know when you're done when you have two fractions added or subtracted together. So hopefully you understand every little piece till the end. So remember, we're keeping it apart. So notice the bottom can be broken apart right here into x minus 2 and x plus 1. This is factored into two pieces. If you need some review with factoring, I highly recommend looking up the videos on YouTube. They're super helpful, and it doesn't help to review. Now let's start doing the partial fraction part. So this is where it gets interesting. What I'm going to do is I'm going to actually break it apart on purpose. So I'm just going to put an unknown thing, let's call it a, and I'm going to put it over one of the factors, x minus 2. And I'm also going to add it to another unknown letter, let's call it b. I'm going to put it over the other factor, which is x plus 1. Let's take a moment to pause, because notice right now what I've done is I've just copied what I have on the top. But I just want you to see, notice we're at an equation and we're trying to solve for two letters. We're trying to solve for a and we're trying to solve for b. So you know what, let's make this simpler. Let's make this easier to look at. And to make this easier to look at, what I'm going to do is I'm going to multiply by a common denominator. And I'm going to do it on both sides. So I'm going to multiply by x minus 2 and x plus 1. And I'm also going to do it on the other side, because otherwise nothing would make sense. So notice I'm multiplying by this common denominator, and look what happens. Notice these cancel out with this common denominator. Notice when you multiply this with A and B, a result happens, and I hope it's okay if I write it beneath it. A is going to multiply with x plus 1, and the x minus 2 will cancel out with this thing on the bottom. Notice B is going to be multiplied with x minus 2, and x plus 1 will be multiplied with this on the bottom. So notice that this common denominator made things way easier. And let's not forget about the beautiful 5x minus 4 on the left. All right, so at this point, notice that we are trying to still solve for a and b, but remember the zero product property? So our problem is, how can we get rid of x and possibly get rid of a letter so that we can solve for the other letter, right? So I want to, you know what? I want to substitute x as -1. And think about what happens when I do that. This whole thing will turn into 0. This will be a number. And this will also be a number. So keep in mind, when you substitute x as a number, we can use it to solve for b. And if we used it in the same way, we can also find what a is. And I'm so excited to show you today. So let me go ahead and set it up. So on the left, I'm going to first solve for b first, since that was the first one I brought up. So in order to solve for b, I'm going to substitute x as -1. So notice what happens. We have 5 times -1 minus 4. That is going to be equal to a times -1 plus 1 plus b times -1 minus 2. And I know that was a lot of information, but bear with me here. What we're going to do is we're going to simplify this. And let's start with the funnest part. This part, -1 plus 1, that simplifies to 0. So we don't need to worry about that. Let's simplify this next part. B is going to be multiplied by -1 minus 2, which is -3. And let's not forget about the left side. We have 5 times -1 minus 4. I think that's -9. So let me simplify this a little bit for you. We have -9 equals -3 times b. Hopefully you remember enough algebra to solve for this. You can divide by -3 on both sides, since -3 is multiplying. And you should get -9 divided by -3. You'll get b equals 3. So you've just solved for one of the missing pieces of the fractions. Now notice we're almost done. We just have to also solve for a. So let me change my colors here. So to solve for a, let's think for a second. How can we get rid of b? So basically what we're going to do is we're going to set x equal to a number where it'll make it 0. So notice we can place in a 2 for x to make that factor 0. So I'm going to set x equal to 2. So let's do the whole thing over again, and let's substitute everything for 2. We have 5 times 2 minus 4 equals a times 2 plus 1 plus b times 2 minus 2. And notice we're in this wonderful situation again where this is equal to 0. We have a is multiplied by a +3 this time. And the left side, let's see, 5 times 2 is 10, minus 4 is a +6. So ultimately we get 6 equals a times 3, or let me write it as 3a. Last but not least, we're going to divide by 3 on both sides, and we get a equals 2. Notice what you just found. Let me look at the very top. We have a equals 2 and b equals 3. When you look at the top, notice we've just found these missing pieces. So let's actually write the final results. You did it! You've now found that 5x minus 4 over x squared minus x minus 2 can be broken apart into two separate fractions added together, where the first fraction is 2 over x minus 2, and the second fraction is 3 over x plus 1. So notice this was what we had in the very beginning. It's just this was A and this was B, but you used mathematics to find those missing pieces. Congrats! I just want to let you know that there's tons of awesome other videos to practice this, and there are also different cases. So I highly recommend looking up some more examples. I also have some links in the description as well. Thank you for watching.